it's a module of the engine management system. Like I was saying, the engine management system is a combination of fuel injection and ignition systems. We just want to identify probably the ignition system components that we were talking about. We want to relate the circuit on the board to the module. Of course, we don't have a battery. But of course, there is an ignition switch. If we connect a power supply, that's the ignition switch. So there should be a power supply because this now is a module. And I think you can identify this. That's the coil. And we say this is the transformer. It transforms the low voltage from the if it's on the motor vehicle, low voltage from the battery is transformed to a high voltage. And that high voltage is then delivered to the center of the distributor cap. Inside there, we have a rotor which is driven by the distributor shaft, which is being driven by the camshaft at the camshaft speed of half the crankshaft speed. Can I tell half crankshaft speed is what? Can engine speed really 5,000 revolutions per minute? Distributor speed will be 2,500, half of that. Then we were saying our HT leads are connected in the firing order of the engine. And my HT leads are not connected in the firing order of the engine. Not in the numerical order, but in the firing order. And firing order, common firing order for 4-cylinder engines, I think you know it, it's 1, 3, 4, 2. As you can see here, the spark plugs displayed on this model. Normal spark plugs here. So we are saying the high voltage is delivered from the coil to the distributor. Then out of the distributor, one plug at a time is fired according to a preset sequence 1, 3, 4, 2. At fiber plug is second one because the plug is negative cylinder. So that's basically the ignition system there. Then there is a module there, igniter, that's a control module. In the majority of cases, this is a power stage which is controlled by the main computer. So this is the computer that we were talking about, the computer that controls both fueling and ignition. So a computer is no controller of my injectors, no controller of my spark plugs. So it has since taken over the function of the carburetor and the function of the distributor. On modern vehicles, we now have distributorless ignition systems. Computer learning distribution. Okay, so the ignition system here is put simply here. The ignition system starts from the battery, ignition switch, coil, then from the coil into the igniter, into ground, that is the primary coil. Then the high voltage is delivered to the distributor, into the distributor, then out of the distributor to the spark plug, then to ground, in the firing order of the engine. So, computer E, igniter E. The computer controls the igniter so that the igniter can switch off the primary coil at the right time. Timing of the spark, we need the correct advance. So the computer collects information from various sensors. Let's see here. There's a temperature sensor. You can see this is a temperature sensor. It's a what? We describe the temperature sensor as a silicone. The temperature sensor. Yeah, we said something about the temperature sensor. It's called silicone. It's a thermistor with a negative temperature coefficient, and it is normally embedded, or rather connected to the cooling system. See the cooling system of the engine. As you can see, the position that it is placed here relative to this diagram of the what? Of the engine is somewhere in the cooling system. I am a water jacket sky. You can see that. My water jacket sky. So the temperature sensor is embedded in the cooling system to monitor engine temperature so that the computer can correctly calculate the spark timing, which matches that particular temperature. The computer can calculate injection time, the quantity of fuel required, which matches the current temperature. So the temperature sensor sends a signal to the computer, then the computer, using the software in there, then evaluate and control spark timing and injection duration. But otherwise, I want to believe we can identify major components of the ignition system. We can identify my major components of the ignition system. We can now identify them. tikabva tikaenda pari pamota wakutonokwanisa kunonongedza kuti zvinhu zviye zvataona zviri pamota icho neicho 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 ndizvo toda kuti tabva panapa hatidi kungodzokera kumba tiri blank semaonero ataita panapa tafambirei. Major components of the ignition system, let's identify them.
Then ignite. Side the coil. Ignition in a computer box.
And then we should also mention my sensors. For my sensors, temperature sensor and the temperature sensor. Then the distributor itself, inside the distributor we have a sensor. We have a sensor which monitors the rotational speed of the distributor, as well as to determine the specific point at which the spark is going to be introduced. So inside the distributor, a sensor. We call it a wall type sensor. Diploma distributor there, the two of them. Those two distributors. Is that a distributor?
The distributor.
Wanting to be serious, you don't know what a distributor is. About you are loitering away from here. You are tuned about distributor.
Chubak, Eric. Chubak. The fuel, man.
Fuel, tell you what to say.
I'm just like
that's a chibak is at number. Just with one. This one we call it a wall type sensor. Wall type sensor, wall effect sensor. Look at the number of wall effect. Wall effect sensor and a magnet in cartoon. Then this is a vane. As it is rotating, Kino send a signal about how far the distributor is rotated. In fact, every time when a slot is between this sensor and the magnet, a spark is discharged. The number of slots are equal to the number of cylinders that we have. So, in those sensor, selector timing, send that data, chance of calculator timing a spark. Every time when the slot reviews the sensor to the magnet, then a spark is discharged. So, sensor is of the information in the computer so that the computer can correctly calculate spark timing. That is the distributor sensor. Enjoy pinda position here, crank sensor. For my modern vehicles, we no longer have distributors, but we have a crankshaft position sensor. They will send the information about the position of the pistons as well as timing of the spark. So my sensors are important for the ignition system that we have on this model. They include the distributor sensor, the wall type sensor, and the inductive type sensor. This one we call it the inductive type sensor. The inductive type sensor. This is the inductive type sensor. It does the same thing that is done by this, sending signals. When a spark is required, the signal is sent to the computer. Then the computer switches off the primary coil to discharge a high voltage into the secondary, and onwards the spark plug. So we can alternatively we can have an inductive type sensor or a wall type sensor. So expect any of these. And you should know the operating principles. I think sensors takamaita. Sensors takumaziya. Utonyepa cannot say utonyepa. Whole type sensor takaitaura kakawanda stereo. Inductive type sensor tikati vrema notebook yenyu zvivamwe mutori nayo. Optical type sensor ndoziziva. Alright, let me just break it down in simple terms so that when you go back home you go and research. There are 3 types of sensors that can possibly be used in distributors. The Hall type sensor using the Hall effect, the inductive type sensor using induction, then the optical type sensor which uses LEDs and phototransistors. It is based on what? Based on light. Okay. So that is your ignition system, but it's part and parcel of the engine management system. It's combined with the fuel system. There's a fuel system. Fuel system. We are not engine management system on a model. Now let's look at the fuel system. Fuel system is very simple. We are managing the delivery of fuel. The correct quantity of fuel should be delivered in order to match the power requirements of an engine. This one we call it multi-point injection. We have an injector per cylinder, and this is illustrative of a fuel rail. The fuel rail is supplied with fuel at a pressure, and that pressurized fuel is then discharged into the inlet manifold. When a pulse is delivered at an injector, that pulse is coming from the computer. The computer calculates the length of time that the injector will stay open to deliver the correct quantity of fuel. Okay. My injectors operate when a digital pulse. I remember we now know the difference between digital and analog. Digital, what kind of pulse is it? What kind of signal is it? Digital signal. These are things that should be at your fingertips. Kumutswa pakati peusiku kuvunzwa kuti digital neanalog zvakasiyana papi. You should know, yes?
Digital inenge ichama analog
ma-1 apa. Toda kuti titaure in very specific terms, maziro zvema-1s andi apa.
anenge achideka kusei kuti
wakutiudza wefomu yacho, but can you describe it? Or it's a signal which occurs at 2 voltage levels, on and off, high and low, and then 0 and 1. Don't know about 0 and 1. 0 off, 1D on. So an on-off signal is applied to this injector. When switched on, it opens to deliver fuel. When switched off, it closes. No fuel should come out. Those digital signals are generated by the computer. And at least, what's the problem? You are taking a video about you are spoiling it.
No, sorry.
You are spoiling the video. You have to edit off that part. You have to edit off that part. That part will have to be edited. Alright, alright, okay. That's the fuel delivery system. Your fuel delivery system, we start from the tank. There's a tank, in the pump. This is the pump. This illustrates the pump. Yeah. Pump, draw. So this is the pump. Then there is a fuel filter. That's the filter, which then delivers fuel to a fuel rail. And then from the fuel rail, we do have pulses that are applied, digital pulses that are then applied onto the injectors to open and close the injectors. The correct length of time to deliver the exact quantity of fuel is required by the power requirements of the engine at that point in time. Is monitored by sensors. So your fuel system is quite simple. From the tank we have a pump, then the fuel is pushed through a filter for the removal of solid suspended particles. Then it passes passes into the fuel rail where it is distributed to the injectors. Then we have a pressure regulator. The pressure regulator returns excess fuel to the tank in order to manage the fuel pressure behind the injectors.
Sorry, sir.
Yes. My injectors. I know my injectors. No fuel really. Can proceed.
My HD cable.
My HT cables in the eye. My HT cables are ignition system.
HD cable.
HT. HG is about entertainment systems.
Say, and my injectors learning guide from I think I supply fuel my cylinders.
My cylinders. Saka per model panapa illustration is panapa. My cylinders they didn't wire. We don't have an engine now. But can apply on the real car. The fuel rail and the injectors are connected to the inlet manifold. Panic by inlet manifold. When injector in its particular cylinder. So in this case now, fuel is delivered to the fuel rail. Fuel is delivered to the fuel rail, and when an injector is switched on, fuel is then delivered into the inlet manifold. Can apply per engine. Combustion chamber, then compressed and ignited. Saka pa model enega hapana hapo engine.
Iyo ipipe kuzodai basa.
Ipi. Apa. My injectors they switch on this thing actually to deliver fuel into these portions. Then it will then drip back to the little tank that is behind. A model to illustrate how things happen.
So I say, in Panibana, not like and the other you cylinder. That diagram I draw out. The diagram is behind. You know what I just
In diagram, my cylinder.
So meaning to say, my cylinders have to do any guard per se and
injector in my injectors are each and every cylinder I didn't get one injector, one spark plug. Spark plug, the injector, spark plug, the injector. Okay, we may say this is for cylinder number 1, you didn't get it per 1 off it. 2, shida. Every cylinder is its own spark plug and injector. Yes.
Injector and one pins on plugs.
Those are two. On each and every cylinder, we have a plug and an injector. The plug is for igniting the fuel, the injector is for delivery of fuel. So fuel is delivered by the injector, then ignited by the spark plug. Fuel is delivered by the injector and then ignited by the spark plug in the firing order of the ignition. And Pansi. This guy is good viral. They compensate. You know what people compensate? People who don't know want to pretend as if they know by laughing at those people who are trying. It's compensatory behavior. It's psychology.
What is psychology?
What is psychology?
Ndakakuudza wani kudhara kuti hatina kufanana.
Very soon.
That was very offensive.
That was offensive?
Yes, very.
Stating effect.
Effects.
Some of the facts are...
That was unnecessary, see.
Who determines the necessary and the unnecessary in here?
That way not effect.
Ayewa. Ayewa.
Alright, you can switch on.